What are we talking about today? So another way you could know that we're talking about systems of nonlinear equations besides the fact that it says. Oh yeah, it's on the board. Okay, awesome. Okay. What is a system of equations, first of all? If it just said system of equations, what does that mean? What are we looking for a system of equations? Have you ever heard of those words together before? Oh, so we did them already in here? When? For 6 weeks? Did we do a big project related to systems of equations? Oh, out in the hall with the QR codes? Okay. So does that help you think about what a system of equations is? What are we looking for? Points of intersection. That's right. Okay, we're looking for the points of intersection. We're graphing things and see where they cross. We're solving things with substitution or elimination. Now, does that help bring more vocabulary words back to your brain? Okay, so first of all, we're going to do that today. We're going to do graphing. Solve a system of nonlinear equations by graphing. We're going to solve by substitution. And we are going to solve by elimination. I'm going to show you examples of all three of those. Okay? Which one's your favorite? Back before, which one of these are your favorites? Okay? Most people today have said graphing because they let the calculator do it all for them. Okay? But substitution and elimination, those are both easy, right? You guys got really good at it by the time we were done. You obviously don't remember what you did 2 months ago, but that's okay. I'll forgive you. And I'll show you what to do again. Is that fair? Okay. Let's do graphing first. So this is the system I wrote, and earlier they argued with me. Anybody see why they would argue with me about this? That's a line. Y equals x plus 4, that's a line, isn't it? Didn't I say we were going to talk about nonlinear equations? Or did I say we were going to talk about systems of nonlinear equations? A system. Okay, a system of nonlinear equations is allowed to have a line in it. It's just not all going to be lines. Okay? This is a line and this is a parabola, right? So I have a line and a parabola. Think about a line and a parabola real quick. This is just a little commercial break over to the side. If I have a line and a parabola, how many times can they intersect? So twice. That one's probably easy to think about, like that, maybe, where I have one solution here and one solution there. Is there any other possibilities besides two solutions? One solution? How would that work? So if I had a parabola here, and a line went like that, and touched in one place, that would be one solution. It doesn't have to just be this way, it could be this way, right? As long as it's tangent to that. Is there any other possibilities? Oh, no solution, right? That one's pretty easy to think about. Just doesn't touch, right? So, are we really at this point in our lessons talking about imaginary solutions anymore? No, not really. Not when we physically have a parabola and a line that we're trying to see where they cross. Okay? So we're mostly talking about real solutions. So what I wrote was two solutions, one solutions, and no solutions. What I meant and what I should have written was two real, one real, and no real solution. Is that fair? Okay? So this is the kind of thing that we're thinking of. Now we know that the parabola could be opening down, right? In any of these examples, the parabola could be opening down. If the parabola opened down in this example, it would have to either be below the line or the line would just have to be higher, right? So that didn't cross at all. Those are the things I want you to think about when we're trying to figure out where the solution or solutions are for this. Is that okay? So if we're going to solve it by graphing, what is the best way to do that? Calculator. Please remember, every day when you come in here and you turn your calculator on, you're starting a new document, right? You're going home to new document. Do you remember that? Okay. Make sure you're doing that. That's all I'm asking. If we're solving by graphing, literally what do? X plus 4. Enter. Tab. X squared. Absolutely. What am I looking for? The intersections, right? The points of intersection. Or point, or the lack of any points of intersection, right? How many solutions does this system have? 2. So how many different times am I going to have to do what I need to do in the calculator? Twice, right? What are the steps that I take to do this in the calculator? Menu. Analyze. Intersection. And then that's the answer? No. Now it's asking for lower bound and upper bound. That means I've got to put this on the left-hand side of the point of intersection and the right-hand side of the point of intersection. It says my first solution is at negative 1.56, comma 2.44. And then I have to do this again, right? Menu, analyze, intersection. Lower bound, upper bound. Do you see it actually show up before you press the second click? Okay, good. 2.56, 6.56. And then, yeah, that's it. We're done, right? Those are my 2 points of intersection. That's my solution. Do they get harder than that? Like you're literally putting in the graphing calculator to press the points of intersection. I could have you graph both of these lines, right? If I was feeling really angry. Because these are not easy points of intersection to find, are they? Okay, so these kind of points of intersection, you need a graphing calculator if you're going to solve it by graphing. Got it? Knowing that these are not nice, pretty points, is this probably the best way to solve this if I don't have a graphing calculator? No. Which way would be better? Substitution. Why substitution specifically? Because they're both y equals, right? If they're both y equals, can't I just substitute what I know y equals into the other equation? Yes or no? So I have x squared equals x plus 4. What type of equation is this now? It is a quadratic. Okay? It's a quadratic because it's got a squared in it. What are the ways that you know how to solve quadratics? Factoring, graphing, can we talk about that one in a second? Okay. Can we talk about that one in a second? Okay. What about square roots? Completing a square. And it's just me being picky again, because you guys said quadratic equation. Guys, this is a quadratic equation. What we use to solve it is the quadratic formula. Does that make sense? Okay. I did hear some people say discriminant. Do we use discriminant to solve a quadratic? What do we use it for? Find out how many solutions there are, right? Okay. It doesn't give us the solutions. It tells us how many we have. Okay. So I'm glad you know the word. That's good. Okay. But we just got to remember what it's for. Is that fair? So, can we solve this with square roots? Can I just take the square root of both sides? Well, I could if this x wasn't here, right? But since there's an x squared and an x, I can't use square roots, can I? Well, we already decided we don't want to do graphing because we already did it and it's messy. Factoring, completing the square, and quadratic formula. Those are our choices that are left. Pretty much any of those ways it needs to equal 0 to start with, right? So let's go ahead and get it equal to 0. Subtract x, subtract 4. Is that the only way we could do it? Why did we do it that way then? We want to keep our a term positive if at all possible. Excuse me. Now that it's here, oh, that looks like a nice, easy factoring problem, right? Okay, what multiplies to be negative 4 and adds to be negative 1? Uh-oh. Nothing, right? Negative 4 is only 1 and 4 and 2 and 2. None of those will add together to be a negative 1, will they? So I can't do factoring, I can't do graphing, I can't do square roots. I already know what the answer looks like. If I think about doing completing the square, what am I going to start to see really, really quick? Fractions. We put up with fractions when we have to. We don't go searching for them, do we? We're not afraid of them. We could beat them down, right? We could. Maybe not by ourselves, but with a friend, we could beat them down, okay? But if you know this way works every time, can we just do that way? Okay? Let's do the quadratic formula. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. So when we did this the first time, and even the second day we talked about quadratic formula, we said just do it, and when you get an answer like 1 plus or minus the square root of 15 over 2, that's a perfectly fine answer, isn't it? Because it was, right? Except what are we looking for right now? We're looking for an exact point of intersection. And while 1 plus or minus the square root of 15 over 2 is an exact number, it doesn't mean anything to me. I can't go graph 1 plus or minus the square root of 15 over 2, can I? Okay? So that creates a problem, doesn't it? What I actually want to do is get the decimal for this. And I almost said exact decimal, but that's not true because it'll be rounded, won't it? Okay? So I want to go to my calculator.
Miss Kingston?
Yes, ma'am?
You have Paige Courier?
I do.
Can you send her to the office? She's leaving.
Yes, I will.
Thank you.
Paige, you got to go to the office. You're leaving. Okay. I'm going to add a page that's a calculator, except not like that. There, really not like that. Add a page. There we go. That's a calculator. I'm literally just going to put all that in. Okay? I'm going to make myself a fraction. Not myself, but in the calculator, I mean. 1 plus the square root of negative 1, making sure I remember my parentheses if I'm going to put it like that, minus 4 times 1 times negative 4 over 2. Enter. X equals 2.56155. Is that it? No, because I only did the plus, right? Do you remember how to go get it so you don't have to put it in all again? If you up arrow till that's highlighted and then press enter, it'll bring it down again and you can arrow over and subtract. Negative 1.56, 155. So is that my point? Is that my point of intersection? Like, just put parentheses around this? Why not? Oh, that's just x equals, right? X equals this and x equals this. If x equals this and this, how many points of intersection do I have? I have 2. One of them looks like 2.56155, comma something. And one of them looks like negative 1.56155, comma something, right? How am I going to figure out what that something is? Well, that's the y value, isn't it? Don't I have 2 equations right here that equal y? So can't I just put the x in there to solve for y, right? Do I want to add 4 to the x or do I want to square the x? Doesn't matter. Since they both equal y, it doesn't matter. Can I show you that it doesn't matter? Okay, I'm going to use this one right here because it's the last one on my calculator. Okay, I'm going to say plus 4. And it says 2.43845. And then I'm going to use that one again also, and I'm going to square it. Oop, I better put parentheses on it though because it's negative. It'll be mad. Oh my gosh, it's exactly the same. Either way, it's 2.43845. Okay? Which one is easier for you, adding 4 or squaring? Most of the time I can add 4 in my head faster than I can square something, right? If I ask you to square this number right here, can you do it? No, me neither. Can you add 4 to it? Oh yeah. 6.56155. I added 4 to this x value because if I substituted it into this first equation, I would take the x value and I would add 4. And that would give me the y value. It does not. It does not matter which equation I choose because both of them equal y, so I should get the same answer for both of them. Guys, these look different. I got this one when I graphed it, and I got this one when I did substitution. Did I do something wrong? Why not? How do you know that? Oh, so when we graphed it, the calculator rounded? So which answer is actually more correct? This one's actually more correct, right? This bottom one, because it has more correct decimal places. But for the record, this one is even rounded. Because right now my calculator is set to round after 5 decimal places. Wouldn't it go on and on and on and on and on? Excuse me. Did you notice that when I chose to add 4 to this, look at what number it actually pulled up? That's the number I used. It actually pulled up that one right there. That's a super long number. And that one's even rounded. Okay? How about if we just decide all together as a group how many decimal places we'll round to on tonight's homework if we get a decimal? Are you okay with that? Let's go to the 100th. How many decimal places is that? 2. Okay? 2 decimal places. So if we actually rewrote this answer with 2 decimal places, what would it look like? Yeah, this one, wouldn't it? Oh my gosh, it's almost like it was the exact same problem. Oh, yes, it was. Okay, excellent. I'm glad you noticed that. Excuse me. All right, what do we have left to do? Elimination. So we did graphing here. We did substitution here. I forgot to underline it. Sorry. Let's do elimination. I'm not going to do exactly the same problem with elimination. Are you okay with that? I'm sorry if you're sad. There's tissues back here if you're going to cry. Because I got to do a problem that looks like this for you. So when I wrote that down earlier, what do you think they did? Yeah, they freaked out. But now you see why I want to do this one for you? So you don't freak out. Okay? What shape is the first one? It's all a mess. It's all scattered on either side of the equal sign. I know that, but what shape is it? It's a parabola, isn't it? It's got a y, it's got an x squared, and it's got an x. And it's got a constant. Isn't that just a parabola? What's the second one? Second one's even easier, right? It's got a y and an x squared, so I know it's a parabola. It doesn't even have an x term. It's just got two x squared terms, so I just put them together eventually, wouldn't I? Okay? I could set these both equal to y and graph them or use substitution, right? But I'm showing you elimination on purpose on this one so that we can actually do an example of elimination. When we do elimination, what are we trying to do? I'm trying to eliminate a variable. I'm trying to make one of the variables go away. Elimination can get tricky if you let it, because if you decide you're going to eliminate the y's, you got to eliminate all of them. If you're going to try to eliminate the x's, you got to eliminate all of them, including if there's an x squared and an x. If I'm going to eliminate x's, I have to eliminate both of these x's. All of them. Does that make sense? So if you look at this problem, which variable do you think would be easier to eliminate? The y's. There's only one y up here and one y right here. Even if we end up with an x squared and an x, guys, we know how to solve that. We've just been spending all this time with all these things to know how to solve a quadratic. Isn't that what it is if I just have x squared and x? Yeah, so that's nothing to be afraid of or worried about. Okay? So if you want to eliminate y's, there's like 45 ways to do that here. Can I just show you one? Let's get everything on one side of the equal sign. Everything. I'm not trying to graph it or solve by substitution, so I don't need to leave the y alone. I can if I want, but let's just get it all on one side of the equal sign. How do I do that? How do I do it for the first equation? So you want to move everything to the right-hand side? That's fine with me. Does it matter? No. So I would get 0 equals... What order do I put it in? It doesn't matter, does it? I'm just going to kind of write it exactly as it's written that we wrote it here, but it doesn't really matter. Does the second equation matter what order I put it in? Oh yeah, for sure it does. I want to line everything up like right below the term that it's like in the first equation, right? So let's add subtract x squared. Ooh, that's going to be nice because I'm losing a term now, aren't I? Not losing it, I'm able to get rid of one x squared term. Minus y. So when I rewrite it, I have 0 equals, what's going to go first? The negative y. Then I need the x squared term next. So I have 2x squared minus x squared. So plus x squared. Ooh. Plus 0x. Do I need to write anything there? But I can put a 0x if I want, right? I don't have to, but she said to, so I'm going to. And then minus 1. Now if I'm eliminating, if I'm going to try to solve this system by eliminating, what do I do now? Yep, I combine them. That's exactly right. What's 0 and 0? Awesome. Oh, look at this. Y and negative y. That was my goal, right? To get rid of the y's. I had them opposite signs. If they're not opposite signs, what do you need to do? You can do some multiplication, right? Maybe if this is a y and this is a y, I multiply everything here by negative 1 to get them to go away when I combine them. But look at this nicety. That's also 0, isn't it? So I end up with 5x minus 30. 0 equals 5x minus 30. Is that something you know how to solve? Oh, yes. Plus 30 plus 30. 30 equals 5x. Perfect. X equals 6. That's exactly right. Now I'm done. I'm not? I'm not done? Why? I found x. Oh, I got to find the y because I got to find the point of intersection. Okay. Good job arguing. Politely. How do I find y? Which one? They're both a mess. It doesn't matter. Bottom one, okay. 6 squared plus y equals 2 times 6 squared minus 1. Everybody see where that came from? Anywhere there's an x, I put in a 6. So I put a 6 there and I put a 6 there. 36 plus y equals 36 times 2, 72 minus 1. 36 plus y equals 71. I want to subtract 36 from both sides. Y equals 35. Now I'm done, right? What? Do I need to? So what's confusing about this is on this one right here, we found x was this and x was this, so we had to plug them both in to get the other y's, right? What did I find here? I only found one value of x. Excuse me. If I only found one value of x, how many points of intersection are there? Or how many point of intersection are there? Just one, right? What's the point of intersection? 635, that's it. For real, that's it. Not me messing with you, but for real, that's it. Can I show you something, though? You don't have to write this down because I don't want it to confuse you. What if I took this 6 and put it in the top equation instead? Because several of you were saying top. Negative 5 times 6 plus 29 equals y minus 36. Negative 30 plus 29 equals y minus 36. Negative 1 equals y minus 36. If I add 36 to both sides, y equals 35. It does not matter which one you put in. Okay? It doesn't matter which equation you go back to, you're going to get the same y value. Does that make sense? Any questions? Graphing, how do you feel about graphing? How about substitution? A little bit okay? And what about elimination? Also okay? Awesome. Okay? If you do have questions, what do?